This video is about replacing special relativity in the scalar theory of everything. I do this by examining the observations that led to the scalar theory of everything. I'm going to make this into a paper, so comments would be welcome. The STOE starts from the book Optics by Newton. It interprets experiments since Newton. It examines data, not the standard conclusions. This makes it kind of labor intensive. The goal here is to explain a wide scope of observations by fewer postulates, such as galaxy redshift and the Pioneer anomaly, with one equation, which was done in the first video. The STOE model is causative and is for forces, not energy, and these forces cause changes. It is Machian, that is to say that the entire universe participates when you drop a pencil. It is fractal, that is to say self-similar. All size scales use similar concepts and equations. The physical laws are the same everywhere. The issue then is to discover those laws, and it makes inflation in an infinity universe kind of difficult to conceive. This video explores how the STOE applies to special relativity basic observations. It suggests the measurements should be in relation to the plenum density, rho, and the divergence of the plenum density, del rho. This triggers the Machian and causality characteristics of the universe model, and the relation of observations of the big in cosmology, the classical, and the small size scales. The development of special relativity was based on some observations. The index of refraction in the Fizeau experiment and the aberration of light, on Maxwell's equations, and in particular the moving magnet and conductor problem, which was a problem in Maxwell's equations, and the negative ether drift experiments, such as the Michelson-Morley experiments and other experiments like them, and it resulted in observations which suggested the Fitzgerald-Lorentz equations. You may remember this image from the first presentation. You will note that the photons coming in from the left tend to go towards the mask. So here we see a surface of a material represented by the dots and light coming in from the left, and you'll note that before it reaches the surface of the material, the light starts to bend towards the material. This has been noted by several experimenters. Note the similarity then to this change of angle to the Huygens assumptions. A few years ago, I tended to investigate the refractive index of glass relative to air by examining a diffraction pattern with two pieces of glass with an air slit between them. What I expected to see was a diffraction pattern, which would then be related to the index of refraction. What I saw instead was an interference pattern. That changed the experiment from being a diffraction experiment to being an interference experiment with a transparent mask. An unexpected result, but a happy result. You may remember in the first video the explanation of how light achieves coherence, or how photons achieve coherence. Here we have a plenum density. In a higher plenum density, the photons travel faster. In a lower plenum density, they travel slower, which means over a period of time, they're all going to tend to line up in a given trough. Now, as a photon or an atom moves, they all tend to line up in a line, and that's coherence. As demonstrated in the Fizeau experiment, the C increases in the direction of fluid flow and decreases when it is against the fluid flow. That is, the immediate environment of the photon determines the photon's trajectory and speed, just like it did for coherence. I call this effect carry-along, not drag. The speed of light is dependent on rho. The greater the rho causes greater tension in the plenum and thus has a higher speed of light. As the body moves in the direction of the photon spends more time in the relative peak of the row. Thus, the photon is carried along at a slightly greater speed dependent on the refractive index. In the Michelson-Morley experiment, the photons are carried along with the air and the room of the equipment, the immediate rho and del rho of the environment, hence the near null result of the experiment. Note, the experiment has a del rho of the Earth, Sun, and Moon leveled as explored in the reference paper. The theory behind the Michelson-Morley experiment is inconsistent with the Fitzhugh experiment. Maxwell's equations suggest fields that transform according to Lorentz equations. The STOE posits HODs are permanent magnets. EM radiation signals are HODs because they travel at the speed of light. Coulomb forces travel at many times the speed of light, and therefore it is a plenum effect. This is denoted in the DeSangro paper here. The moving magnet and conductor problem of the Maxwell's equations is also known as the Faraday paradox. If a magnet is in motion in a laboratory and a conductor is stationary, the electric field arises in the conductor. If a conductor is in motion and the magnet stationary, no electric field is around the magnet. The STOE has noted an inconsistency between Faraday's law of induction and Ampere's circuit law. That is, there are two different types of magnetic field, and that is explored in the paper that you see there. Faraday's law of induction is that a permanent magnetic field moving produces an electric field in a conductor. A changing current in an electric field produces an electric magnetic field. This is the Biot-Savart law. You'll note that a cross product of the current introduces a magnetic field at some point. That is to say, the current along the entire length of the wire produces that current. That is what we're going to explore with an experiment. The integration is around the entire circuit. Here I have two disc magnets. If you'll note that if both sides north is up, they repel. If one is north and the other is south, they attract. We're going to use this to detect current in the wire and the resulting magnetic field. Here is this magnet. I've attached it to a piece of wood and mounted it on a weight scale. Now there's a small gap of about 0.5 millimeter here, and we've attached two wires that's going to provide current. Here then is a multimeter. I turn it to the resistance range, and you see it's measuring about 0.4 of an ohm through this current path. Let's change back to voltage. Here is the battery, and what I'm going to do is attach the terminals to the battery. Now this is not, there's some problems here. When I attach the terminals, the battery is going to provide a lot of current. It's going to actually discharge the battery faster than it should, and therefore things are going to get hot, and the battery's not going to last too long, and the current level is going to be varying. So we need to be quick about this and not take too much time in the actual measurement. I've attached one terminal. I'm going to turn on the scale, the weight scale. It's reading 0 because it's zeroed with that weight on there. So, let me attach the battery. You see that we're measuring a voltage, which means the current is flowing. And this is reading 0.36. Now, for the first experiment, I've changed the terminal direction, so the current's going to flow in the other direction. Attach the battery again, and this time I'm measuring minus 0.38. Now, that means instead of being attractive, it's repulsive, and therefore the current in this brass bar is actually pushing the magnet. The next experiment is to move the electrodes here very close to the magnet. Now we're measuring 0.39, which is very close to what we had in the full length of the magnet. That means the current and the magnetic field produced in this part and this part are having no effect on the magnet here. It's only the current over the magnet. To see this, let's do one more little test. Here, all of the current is going to be on one side through the brass bar here and not over the magnet. We're getting a voltage reading, we're getting current, and the reading here is 0. That is to say, there's current flowing here, but there's no magnetic force being exerted on that magnet. This means the Biot-Savart law is rejected.
The experiment indicates the magnetic effect is ejected from the wire perpendicular to the wire, but not at any other angle. This is also experienced in radio signal antennas. The STOE suggests the HODs have a magnetic field and travel at the speed of light compared to the plenum wave, which travels at many times the speed of light. This is a diagram depicting another experiment we're going to do. We have a coil of wire that surrounds in a magnet, which is in the middle. In the STOE model, only current from perpendicular to the wire will have an effect as depicted in the C2 areas with delta equal to 1. In the other areas, perpendicular to the wire does not overlap the magnet. Magnets on a scale, and I'm going to measure the force that is exerted on the magnets by the coil of wire. This is the coil of wire with a power supply that's going to provide about 1 amp of current. We place the magnet in the coil and measure the force that when the current flows. In the center, here as you see, and later on at various radii here near the edge of the coil. This is a plot of the result where the force at some radius is compared to the center force, and the bottom line is both the data and the STOE line plotted, and the upper line is what the Biot-Savart law says it should be. You can see that the actual result agrees with the STOE and not with the Biot-Savart law. Faraday's law concerns moving magnets, so we're going to drop a magnet through the coil with a voltmeter attached. The voltage measured from the center drop to an edge drop was the same. This suggests that a magnetic field induction is dissimilar to the electric field characteristics in the Biot-Savart law. Free space in the STOE is a plenum without HODs, so a vacuum in a lab surrounded by walls, which are HODs. Thus, the plenum density at a point rho is modified by the Hod's matter around the point, and there is no such thing as a true void in the STOE. In the field equation of relativity, space-time can be warped and it can direct matter. This is the plenum, or aether in some other models. Or space-time could be a mathematical mapping which has no reality, and the S&T parameters then are fictitious parameters with no real meaning. That is, space-time must be inverse mapped to calculate something. The distinction comes when you want to calculate the value of the speed of light. If you use the S&T parameters to do that, it's a false indication of the true speed of light. Either that or you must accept the gravitational aether. Now we can take a look at Maxwell's equations, the epsilon and mu. In a string analogy, or you could air pressure or any other wave equation kind of analogy, you'll notice that the velocity in a string analogy is equal to the tension divided by some inertial length. In the speed of light, we have c is epsilon mu inverse square root. Remember now, the Hod is a magnet which warps the plenum density, which causes gravity observations. That is to say, the Hod causes a tension field in the plenum density. And by the idea of the analogy with tension, the plenum has the property of inertia and is the inertial mass of bodies. So the tension then corresponds to the inverse mu, and the speed is then the inverse mu divided by the epsilon, or relative to the medium. So now we have an operational meaning of epsilon and mu. Behind the magnetic tension and the electric resistance is the perpetually moving plenum wave, triggered by the movement of Hods. These waves in the plenum then cause the Hod to move perpetually at maximum speed in the direction of zero surface area. That is to say, remember, Hods are two-dimensional. So here are various measurements of the plenum speed of gravity. Laplace measured it at millions of times the speed of light, and so did Van Flandern. Now, Lorentz, Poincare, and Einstein used the left side of the field equation to measure it at c, but as I mentioned before, S and T are false parameters. Another plenum speed application is in quantum entanglement. In quantum mechanics, states are in superposition until they are measured. Einstein attacked this with the EPR experiment, a very core idea which is the base of all the math of quantum mechanics. The STOE model of diffraction is that it is both a wave and particle phenomenon. Now, the photon speed is greater in higher plenum density. The photon causes a wave in the plenum, which is dependent on the number of Hods in the particle. Go to a mall, ask to see the sock color on the right foot of people, then the left foot. The data percentage of time the color is the same. This is a legitimate experiment in QM, but the hidden variable here is that the socks were determined when they were selected, not a linear superposition during the time before they were measured, as QM suggests. In the STOE, Hods cause plenum waves that then cause the direction of Hods. These are the hidden variables. See the photon model of photon diffraction. The plenum density wave travels at the velocity of gravity, which you see is many times the speed of light. Therefore, all interactions are at the plenum speed because it's Hod to plenum to Hod. Now let's look at length contraction. Here you see a rod that has a center of mass, and light is being emitted from this end of the rod towards an observer. Here it is a little while later. The rod is moved. Here's the light wave you saw before, and this are the same distance as you see with the arc here. And therefore, what the observer would measure as the length of the rod is much shorter than it actually is. So the distance shortening that you're going to measure is dependent on the speed of the thing that you're looking at, whether it be light or the plenum gravity wave. Here you see a difference between the two, where by light you measure the center versus the center of mass, and you see there's a small angle here. This is how Laplace and Van Vlandert measured the speed of gravity. Now let's look at the negative result of the ether drift measurement of Michelson and Morley. Here's the paper. This is from Wikipedia, and you see that what they thought they were going to measure is much higher than what they did actually measure, but they did actually measure something. They did detect a difference, but it was much lower and in a different direction than what they expected. However, in the STOE, they should have expected a null result, a true null result, 0. But they didn't, and in fact a direction was detected, as you see here in my paper. With the Miller experiment, the position of the Earth, Sun, and Moon at the time of the measurement was also considered. The measurement was not a wind, so experiments reject the notion of wind, but not that of an ether. That is to say, ether is not particles. The del rho of the Sun and Moon was at right angles to the effect. Thus, it was a rho effect. Fitzgerald and Lorentz, in their Lorentz ether theory, assumed a real contraction of material in the direction of movement. The STOE suggests this effect is real. The STOE speculates that Fitzgerald may be correct. The contraction that he speculated about may be the distance between atoms or between Hods caused by the plenum density, the rho, not the del rho. This can help explain black holes near the sources in our Milky Way and the collapse of black holes causing periodic X-ray bursts from the center of the Milky Way. Photons are a column of Hods as shown here. For bodies larger than the photons assemble in a structure. Here you see photons crossing other photons, which is a very stable structure for bodies larger than a photon. This structure is a neutrino. The STOE speculates that with higher rho, the distance between the Hods reduce, such as seen here. The ends of the neutrino, then, those photons become very loose, and this structure can disintegrate easily. This assumption was used to help describe photon diffraction patterns in the computer simulation. It has been successful. Black bodies, being bigger assemblies of photons, simply disintegrate in very high rho in the center of our galaxy, and they become X-ray bursts. This demonstrates a connection of an electron in the STOE by a photon to the nucleus of an atom. There's the photon, and there's the electron. These are all Hods, and if the Hods reduce in size, that length is reduced, which makes the whole atom smaller, which makes Fitzgerald's idea of length contraction reality. Now let's consider time dilation. Space and time are passive backdrops where events in the universe play out their trajectories. Space allows movement to and back, its distance between points. Time is in only one direction, the arrow of time. It is the duration between events. Processes are not symmetric, as current physics suggests, because of entropy. The standards used in physics are usually assumed to be constant. This is false, but the uncertainty is within limits which can make the resultant models usable. Usability works by allowing uncertainty adjustments, such as done in a GPS system. Measurement standards should be relatively constant for each experiment. Even better, they should be assumed to be constant throughout the universe, but this is hardly true. The speed of light, which is usually assumed to be a constant, only increases the complexity of models. Space, or rather distance, is measured with rods and may vary with conditions such as temperature, but we know the variation and we can account for that. Clocks are assumed to have uniform duration between the ticks. A clock consists of two parts: the physical process, that is, repeating, and the counting mechanism. If either varies, the uniform assumption is violated. Therefore, the use of a clock is really just comparing one physical process with another. The time abstract concept is a misinterpretation in physics. The pendulum process, as in a pendulum clock, has the advantage that we understand the process and its response to various conditions, such as the acceleration forces. The atomic clock has the disadvantage that we do not understand how the decay works or what triggers the theoretical random process. However, decay processes have been noted to vary annually, and here's a paper that discusses it. Many other papers by Fishback and his team discuss this. A possible model is that neutrinos from the sun trigger the nuclear decay that we see. Science provides us with a mechanism that can help humanity survive. Postulates provide a base to provide the predictions. Science uses standards to compare measures to which mathematics, numbers, and geometry may be applied.